Hi everyone, this is Devan Pradeep. Today I'll be explaining Palindrome number. Generally, in any question before entering into any coding question, we need to understand what is the question is. So let's understand what is Palindrome number. Palindrome number is the number. If you read it from left to right or right to left, it's the same number. Here in the case of x is equals to 121. So if you read it 121 from right to left or left to right, it's the same 121 number. But the same number is not a palindrome if the number in the negative if a number is negative integer. If you read the number right to left, it becomes 121 minus, which is not same. As you can see here in the example 2, they mention about it. So by reading this condition itself, you may got an intuition that how to do this problem, which is nothing but reversing the number, so that you need to compare the reversed number with the original number. If both the numbers are same, then it's a palindrome. Otherwise, it's not a palindrome. Here there are two approaches. Approach one is not taking extra space, and approach two is taking extra space using extra memory, which is order of n. I will explain both the approaches how to do it. Let me explain the approach one. Before explaining the approach one, let's think how to reverse a number. Reversing a number, which is nothing but reversing the positions of the digits, the powers. Here, let me explain clearly. So if you see this number 121, here what's the position of 1 here? It's 10th position, 10 position, right? What's the power of 2 here? One is single digit position. Sorry, my mistake. And what's the position of 2 here? It's a 10th position. And what's the position of 1 here? It's hundreds position, right? It the same at the deep level. If you understand this question, which is nothing but if you change the positions of the number, not randomly, uh, reversing the positions. If you change this position of 1 to the last position, it should see the same 100 position or zeros position or something. It should be the same number. So here we are nothing but we are reversing the positions by making this position last position as 100 here and making this last position as 0. It just reversing the positions. If you reverse at the deeper level, now you get that if you reverse the positions from the left to right or right to left, it should be palindrome, but not in the case of negative integers, because it doesn't come under this category. So how to reverse the position, which is nothing but you need to multiply this with the 100, right? You need to multiply this with the 10, which is same because it's a middle number, right? You need to multiply this with the single digit one, and you need to and one more thing, if you see this number clearly more, which is nothing but 1 into 100 plus 2 into 10 plus 1 into 1. So if you reverse this number, it should be same 1 star 1 plus 2 star 10 plus 1 star 100. It should return the same. So that's the same logic I'll be using in the approach one. So if you see here, this is the logic I'll be using, which is nothing but I'll be taking each last digit and multiplying that digit with the 10. Uh, you may wonder why you may wonder that why I'm doing this part means only with the 10. You said that I need to multiply with the 100, right? Let me explain with the example. You will get the what the logic I will be explaining. So if you take this step 1, this process will continue. It will be in the while loop, and it will continue until the number of the length of the digits, the length of the digits here. So if you see here, the 10 will be multiplied to this number for the 3 times, which is nothing but a 100 position. You may got a little bit of point here. Let me explain here more detailedly. So in the step one, this box in the step one. So I'll be, what we need to do in order to get the lost position. We just need to model it, and by modulation of it, I'll get the lost digit position here, 1, which is nothing but 1 here. So initially the number will be 0, and I'll be using the temporary variable because I'm applying some logic here, so I don't want to disturb the original value. So it will be 0 slash 10 plus 121 modulation of 10, which, because I need the lost number, lost digit. So here, the modulation of this is 1, and I need to remove that 1, because next time I'll be doing the step again, because I don't want the 1 again, because I want the 2. In order to get the number 2 by using modulation of 10, then I need to divide it by 10, right? uh, because I want this number. How can I achieve that? Because if I do modulation of this thing, in order to remove this thing, I need to do division. It's a simple math. I'll be making video because what's the modulation and division, so that because this logic is used widely across so many problems. Okay, so here the modulation of 10, we in the step one the number is 1, the num value is equal to 1. In the step 2, the num value is equal to 1 here. So multiplication of 10 plus 12, because the temp value is changed to, here in a step 2, the temp value is now equal to 12, sorry, 12. And modulation of 10, because I want a value of 2 here, it's, uh, this modulation is equal to 2. 10 plus 2 is nothing but 12. Now I will be multiplying with the 10. If you observe here, I'm just increasing the digits value, means making that position increased here. I'm totally making 3 times of 10, so that this value is, the digit value is being increasing. So here, in the here, if I multiply this value with the 10, if I multiply 12 with the 10, I'm just increasing the 1 place to 100 place, and 2 place to 1 place to 10 digit place for the number 2 here. So the value will be 120, and plus the last digit again, temp here, which is nothing but 1. So the addition of whole thing is 121. This is how we'll do approach 1. It takes order of 1 space extra, and total computation of time order of n, because it is taking three times, which is length of the digit. And another approach is uh, nothing but converting this number to the string, and checking from left to right. If the number is equal from left to right, it's a palindrome. Otherwise, we'll return in a, false. Let me explain approach one. Let me explain the code. Now let's dive into the code. How to code the approach one. So if you clearly understand, there are two base conditions which can easily avoided, uh, which is nothing but if the number is less than 0, then it's a false. So I can avoid the steps, number of steps. I can reduce the steps. And if the number is less than 9, then it's a palindrome, right? If you read it from left to right, single digits, which are not palindrome. You may wonder, you need to give x is greater than equal to 0 and less than equal to 9. But I'm already eliminating all the numbers which are below the 0. Then I need to do, which is not needed to give that condition here, which is nothing but return true. And on that side, we need to take a temporary variable int, so int temp equal to x. So in order to, and int answer, here answer is nothing but number, the reverse of x, let me take it is 0. And as I am if the temp value is there, because at the end temp will become the zero here, so I can use temp as a breakpoint for the loop. So let me write this logic: num equal to num star 10 plus. I would say that it's better to write logic, even seeing the video also, because most of the people see the video, they will think that okay, I got the logic and pasted the code and don't. If you type the words, sometimes it will automatically think that okay, this is the condition I'm using. So you can deeply know about what I am typing. That's the reason I would say that type the code on your own after seeing this video. Temp by 10, right? Return num. Let me run this and it will work. 1 minute. Just return to star. Okay. In the case of 10, let me see. In the case of 10, would be. Let me see what is the answer. Okay. I need to return the true or false, right? Sorry. Yeah. If num equal to x, then it's true. And one more thing here, less than equal to 9. Yeah. So you may wonder that why I'm writing the long int, because I already did the problem. If it's a number is last digit of the integer, if you reverse it, then it will be out of the integer boundary. So I'm writing it long int. You can try it on your own. It's a homework for you. Submit. And let me write this approach to also how to do it. Yeah, you can see it right here. In the case I'm not correcting the code because I know how to correct the code. I'm just giving a homework for you. uh, so do this for yourself. And how to, one more thing, and second approach, which is nothing but converting it to the string. Let me keep the base cases here. We need to keep a string, and which is nothing but let this be an answer. And I'm using C++ function to string operation x and int n equal to answer dot size. Let not n, it should be right. Let it keep it right. And int left equal to 0. Let me keep it -1 because I need to compare, right? In a while condition, while left less than equal to right, if answer of left not equal to answer of right, then return false. Generally I'm just checking left and right equally, so if that's true then we will increase left, if not we will decrease the right. And then return answer. No, it's written true, sorry. Will work. So this is the condition I'm working mentioning about the usage of long int. It's a homework for you. You need to try. I wantedly make that mistake, and yeah, and submit. because I was one. I spent a lot of the time why it is not working, why it is not working. After so much my effort, I found it. I want to you guys to know because it's needed information. So you for future problems, I don't want to get mess up. That's the reason. Yeah. Thank you. If you have any doubts or anything, please use the comment section, and any suggestions regarding the video, how do you like this, and what are the improvements needed to be done. Please use the comment section. I'm totally open for that. And you can reach out to me on LinkedIn, all of those profiles which are there in the description. Thank you, and see you again with the next video.